So this again is mostly for Allie, and we're going to make a quick video just to talk about the rest of Chapter 5 and make sure that you have all of the notes squared away with that. There's a couple of topics that come up at the end of Chapter 5. First of all, we deal with what's called inequalities in triangles, and that basically boils down to two important rules. The first of those is called the triangle inequality. And what it says is that any two sides of a triangle always have to add up to more than the third side. If you add up two sides of a triangle, it's always going to be more than the third side is. Here's a picture that basically shows that, and it doesn't matter which two sides you pick, the sum of those is going to add up to more than the third side. There's actually, if you just kind of think through this should make sense for why it would end up being true. If you had sides that were less than the third side, like in this particular problem, I'm going to move things around on the screen so we can see the whole thing. But in this problem, we have 4, 5, and 10. Well, 4 and 5 doesn't add up to more than 10, so those sides have a gap. And they'd like collapse down. They wouldn't actually close in to make a triangle. If they were actually equal, what would happen is when they collapse down, you'd actually have a straight line segment. And again, you wouldn't go up and have the point that would make the triangle. So any two sides have to add up to more than the third side. So here's some questions that are asking you, could these lengths make a triangle? And you can look at some of these fairly quickly and figure out whether they're yes or no. For instance, if you add 17 plus 31, what you're going to end up getting is 48. That's bigger than 40, and so yes, that will end up making a triangle. On the other hand, on B, if I add 9 and 12, I get exactly 21. That's not greater than 21, so B, no, it will not make a triangle. Basically, what you want to do is pick the two smallest sides, add them up, and make sure it's bigger than the large side. And here's the answers to all 6 of those, so you can see. Again, the no's, it's because it does not add up to more than the third side. The yeses, the two smallest sides, do add up to more than the third side. Another kind of question that comes up with those, they will give you two sides of a triangle and they ask you, what numbers must the third one be between? Well, all you basically do is subtract and add. If I take 29 minus 14, I get 15. If I take 29 plus 14, I get 43. And so that third side has to be somewhere between 15 and 43. If it was 15 or less, then I'd add up that with 14 and I'd get something that's less than 29. And if it was bigger than 43, when I add up 29 and 14, it would not be more than the third side that we have. So you just subtract and add to get those answers. The other rule that comes up in this section is what's called the side angle theorem. And again, it's kind of common sense. What it says is that the longest side of a triangle is always across from the biggest angle, and the shortest side is always across from the smallest angle of a triangle. Big's across from big, small's across from small, and just right is across from just right. So it says here, arrange these angles from smallest to largest. Well, I know that the shortest side of the triangle is 7, so the smallest angle must be across from there, and that's going to be C. The next side is 10, across from there is A, and the biggest side is 12, across from there is B, so it's going to go CAB. Here it's asking how big is angle A, what's the longest side, and how big could AB be? Well, angle A you could get by just subtracting from 180. And if I take 180 minus 68 minus 29, what I'm pretty sure you get is 83. So angle A's got to be 83 degrees. Since it's 83, the longest side would be what's across from there. And that's going to end up being the one over on the right-hand side. The label got cut off, but it is BC that would be the longest side. The other question is, how long could AB end up being? I'm pretty sure that was the other question, yep. And when I look at that, I know that the longest side is going to end up being BC. AB would be the shortest side, and that means it's got to be less than 15.2. So somewhere less than 15.2 would end up being our answer for that one. There's one other thing that we're doing in this chapter, and I'm going to go over to another app to show this to you. The last section of the chapter talks about what's called the Hinge Theorem, which is something that sounds kind of complicated, but really it's not. What it says is if two sides of a triangle are congruent to two sides of another triangle and the included angle of the first is larger than the included angle of the second, then the third side has to be longer than the third side of the second triangle. This is actually easier if you look at a picture to kind of show what it says. Here I have these little alligator pictures, and basically what it's saying is if the angle that the alligator's opening his mouth to gets bigger, then that vertical distance has to get bigger as well. That's really all it's saying. We've got these two triangles where we've got sides that are the same, but one angle's bigger than the other. Well, the side across from it has to be bigger too. It's kind of like that side angle theorem, but it involves two triangles instead of one. So you might see some questions like this. Here's a picture of a triangle. And we're supposed to put a relationship symbol, either less than, greater than, or equal, between these two things. Well, in this picture, I have sides in the left hand and the right hand that are going to be equal, but the left hand angle is less than the right hand angle. And since that angle's less, that's why AR has to be less than BR, and less than will be the answer on this one. Then it says, is AC or DF longer? Well, again, you look at which angle's bigger, and it's got to be DF. Here we have a picture. It says that AC is 18, AD is 18, and what we have here is two expressions for the angles. And it says write an inequality or a set of inequalities to describe the possible values for x. So on this one, the thing that's important with this is I know that 9 is less than 12. So what I would write here is that 2x minus 3, the first angle, has to be less than 31. So the bottom angle has to be less than 31. 2x minus 3 is less than 31. If you solve that, you'd get that 2x is less than 34, or x is less than 17. And that is what you would end up putting for this problem. You could actually just leave it at the first part, or you could solve it and say x is less than 17. And finally, the last kind of problem I have here, this sounds way more complicated than what you might think. But again, if you look at it, the triangle on the bottom left and the triangle on the right both have sides that are marked with 1 slash and 2 slashes. So they're the triangles we want to focus in on. And I have one of those that has a side that's 15 and one of them that's a side that's 12. Obviously 15 is bigger than 12. So I'd say that 112 is greater than 5x plus 7. 112 is greater than 5x plus 7. If you solve that, you would end up subtracting 7 and dividing by 5. And in this case, we're going to get 21 is greater than x, or you could put it as x is less than 21. So that's the rest of what comes up in this chapter. Hopefully that will help you keep everything straight for what we need to do. And that will finish up chapter 5. We'll be reviewing next week and getting to the next chapter test.